Hello students, in this video we'll discuss about the modifications of Turing machine or the variants of Turing machines. Okay, and so in the last video we have discussed what are the techniques to construct the Turing machine. Let me go with this first. The standard Turing machine can be modified as the Turing machine with the stay option, right? We are moving right direction, left direction, right? Sometimes you don't need to go anywhere. I've already discussed this no direction. They are saying that stay option. It is going to be stay at one place. And Turing machine with semi-infinite type, whatever the model we have discussed, actually that is infinite type only, semi-infinite, only increasing one time. There is a two-way infinite type also. And offline Turing machines, jumping Turing machines, non-erasing Turing machine, always writing Turing machine. We'll discuss about this one by one. First, let me go with the stay option. See here, instead of moving left or right on seeing an input, the head could also stay at one position without moving anywhere. So that we have mentioned directly N, no movement, but actually you'll be having the S, the stay. So it is going to be stay at the same position. You have to do like this. And a particular state, if you read a particular input symbol, what would be the next state? And what is the updated symbol? Where you are moving, whether you are going left side, right side, or you are in the same place that you have to specify. So what is the advantage? Already we have discussed such examples like 2's complement, 1's complement. Everywhere we have, whenever we have reached the delta, we have just stayed there only. But the examples what we have taken from other source, they have gone to the initial state and there they have moved right side, but no way they write the stay or no operate, no movement. So we'll be having such. Then we are having a Turing machine with a semi-infinite type. So actually this is the same thing we have discussed, but we have a two-way open input type Turing machine. So you'll be having here, and the first one is the starting symbol of the input type, and only the end of the input symbol is denoted with the delta. Sometimes even it is the starting of the string is denoted with the delta. So before the starting symbol and after the starting symbol, you will be having opened tape. You can go there and you can do whatever you want, right? That's a semi-infinite tape. And we are going to have the offline Turing machine. See, sometimes you want to keep the changes unchanged. Sorry, keep the whatever the modifications you have done that should be remains unchanged, right? When we are not using the Turing machine also. But the still input file is remains unchanged as changes are made in the tape and not in the file. If you want to keep them unchanged, then you can use the offline Turing machine. Okay, so that we have discussed in the multi-track, right? We are taking the input file, but we are not going to change this. Even though you are modifying it, we have to make this unchanged. So we are using an extra. This tape is only read only. The another tape is read write. You can do whatever change. This is called offline Turing machine. Offline means this is not dynamically changed. And let me go with the jumping Turing machine. In the earlier case, we have just moved left side one cell, right side one cell, or we have stayed it. But sometimes you have to jump from the current cell to directly some n cells, right? So that is also possible with the jumping Turing machines. What you are having here, so you have to specify that left shift or right shift, n, how many cells you have to jump, that you have to specify here. So that if you write here left shift into 3, then the 3 cells will be jumped to the left side. A right shift into 4, then right cells, 5 cells will be jumped to the right side. Like that we can do it. But guys, let me tell you one more thing. But still the language accepted by the Turing machine remains same, not only for this Turing machine or this variant. Whatever the variations you have taken, the modifications, all the modifications are going to accept the same number of languages. There is only one change that we will discuss. That is only in the restricted Turing machines that we will discuss, but remaining all Turing machines are going to accept the same languages, same number of languages. We are having the another one called non-erasing Turing machine, right? So for example, if you want to change the input symbol to blank, then such type, right? See, we can change the input symbol to the blank, but if we remove the facility of changing the input symbol to blank, okay, that is called non. See, if it is A, you can change it to X. If it is B, you can change it to Y. But if it is A, if you are removing the A, changing it to blank, that is allowed in the Turing machine. But if you are removing that, changing the input symbol to blank, then we can call it as non-erasing Turing machine. See, changing A to X is we are rewriting it. Changing delta to epsilon means we are removing it. Or changing Y to epsilon means we are removing that. So if you are blocking this, if you are not allowing this removal of symbol, then we can call it as non-erasing machine. We can replace the input with any other symbol except the blank. That's the meaning of it. And the last one is always writing the Turing machine, right? So sometimes we will leave the input symbol without doing any changes, like we have discussed in the A power n, B power n, right? After making the A to X, we are searching for the B. So until the B, we are not doing anything with the middle symbols. But if you are saying that it is always writing, you have to do something here. If it is A, change it to A again. If it is B, change it to B again. Doing nothing is not allowed. Such Turing machines are always writing Turing machines, right? So these are the modifications what we can do for the Turing machines. Now we have a variations of the Turing machine by adding something extra, right? Something extra to it. We are having 7 variations. Multiple track Turing machine, we have already discussed about that. Two-way infinite tape Turing machine, we have discussed semi-infinite. Now we are having two-way. We have already given some. Multi-tape, you'll be having more than one tape. Multi-tape and multi-head Turing machine will be having more than one tape and more than one head. Multi-dimensional, not only the single dimensional tape, you'll be having two-dimensional tape. And multi-head Turing machine, like multi-tape, we'll be having multi-head. And non-deterministic Turing machine. We'll discuss one by one. So multiple track Turing machine, we have already discussed these guys. So at a time, if you are having two tracks, we can read two symbols at a time. And we can change two symbols at a time. That's your wish. Changing or not your wish, but it allows you to do modifications to symbols at a time. If you are having K tracks, you can do the K changes at a time. Right? And moving left side, right side, everything is allowed. Same. Everything is same like a general Turing machine, except we are having two tracks so that you can read two symbols at a time. You can modify two symbols and you can right, everything is allowed. Then two-way infinite tape Turing machine. See, we have already discussed this semi-infinite tape. There is nothing but one-way infinite tape. So the one end is completely closed and the other end is opened. Right? But in two-way infinite tape, both ends are open. You use whatever you want. Go here and use the space as stack or queue or whatever you want. And go here and use it. There is no such rule that you have to go only right side to do something. Okay, that is true. Now multi-tape Turing machine. What is the advantage of it? See, same. Multi-track is different. Multi-tape is different. Multi-track can read all the K symbols at a time, but multi-tape means you will be having the tapes, but it can read only one symbol at a time, right? So in the multi-tape Turing machine, we'll be having 1, 2, 3 tape like that. So you can mention which tape is doing what, like one tape is only read, one tape is only write, one tape is read write. You can make such modifications to this also. What is the advantage of it? For example, if you are performing the ones complement, then you need both, like we can do it another way. Or if you are performing multiplication, you do the task in another, you use one for input, another one for output. Or if you are checking the WCW, or if two strings are same, store one string in one tape, another string in another tape, and write down the result here. Both are same, okay, well and good, equal, like that. How many different symbols? You can find it. All these things with the multi-tape. Of course, every tape is having its own advantages and disadvantage. What is the disadvantage of this multi-tape? More complexity in the transition. You have to specify which tape you are reading, with which head you are doing, right? If it is only single head, you have to jump from the head tape to tape, that you have to mention. Okay, here earlier what was the standard Turing machine? So on which state, what is the input symbol, right? Then you have to mention which tape you are in. Then what is the next state and what is the modifying symbol, which direction and which tape you are going on. So one extra field is going to be added here by saying that the tape, the next tape. Then we are having multi-tape and multi-head. In the multi-tape Turing machine, we are having only one head that will be jumped from one tape to another tape. But sometimes you may have the multi-heads, right? As I told you, right? You can use one tape for different operations. Now there is no need of jumping the heads, moving the heads. Every tape is having its own edge. For example, if you want to check the string equivalence, so one head is moving and another head, you can do it. Or if you do some other tasks, right, like multiplication or calculations, you can jump from one place to another place. Again, the complexity will be more, right? You have to tell about the which tape and which head also. Earlier we have done with only which tape, but here you should know about the tape and also the head. And coming to the multi-dimensional tape. See, so far we are having only single dimensional, so that we can move from left side or we can move from right side. But in the multi-dimensional, you can move downside and you can move upside. We are having four directions, right? Four directions. So for example, if you are here, left, you have to specify left or right or up or down. You have to specify same. And Q naught, if I read input symbol, which state we are going, what are the symbol you are modifying, and which operation you are doing. So here the possibilities are right, left, up, and down. There is advantage of two-dimensional tape. So the only thing is we are having extra directions. That's it. So multi-head Turing machine. We are having single tape but more than one heads. For example, in palindrome you can check it. Check both head and first and last symbol. Head 1 symbol and head 2, 3 symbol are same. If both are same, move this head left side, right side, and move this head left side. Like that, you can cross verify it if you are having two heads. Right? But what is the advantage? Time will be less. But what is the disadvantage? We should take care about the heads and the single tape. Sometimes there is a collision between the heads, which is moving left, which is moving right, where we are going. So some definitely there is a design complexity while you are constructing the Turing machine. And we go to the last one, the non-deterministic Turing machine. See, deterministic Turing machine means for every input symbol, if you take any input symbol on a particular state, then it will go to the same state by changing the same and direction is same. Only one moment. For QA, you'll be having only one situation. Like DFA, DPDA, same thing, right? Deterministic. But non-deterministic means for the same situation, you'll be having the two different computations. For the same situation, you'll be having the more than one different situation. Some may take you to the accept, some may take you to the reject. We are not worrying about. Some may take you to the infinite looping. But if we can say that if we are having only one path where it is taking accept or reject, that will tell you, but it is more than one path, at least one path should be accepted to tell that the string is accepted, right? Same like DPD and DFA, but here you should mention that the same state, same modifying symbol, same direction. If anyone is symbol, if anyone is different here for QA, if anyone is different, that is a non-deterministic. You have to take the more than one path. So that is about modifications and variations. So in the next video, we'll discuss the Turing machine as enumerator.